Today we're going to talk about graphing a sine and cosine function. Okay, so first we're going to go over some vocabulary. The sinusoidal axis is the horizontal center line, which we'll abbreviate as CL. That's the horizontal center line of the curve. Okay, so right here, this is the horizontal center line. So I'm going to call that my center line. It's also the sinusoidal axis. The amplitude is the maximum vertical distance above or below that center line. So here's an example of an amplitude right here. And here's another example of the same altitude. I can do that in any interval here. The distance between the center line and either a maximum or a minimum is the amplitude. So that's the maximum vertical distance above or below the center line. A cycle, this right here in blue, is one cycle. Okay? It's along the curve. Until it repeats. So if I start here, go down and back, now it's going to repeat. So that is one cycle. No matter where I start, one cycle is until it repeats. So if I started here, go down and up and back, and that's one cycle. A period is the horizontal distance of one cycle. Okay, so I've got a cycle highlighted here. A period is the horizontal distance of that cycle. The frequency is 1 over the period. So whatever the period is, the frequency is the reciprocal of it. All right, so number 1, sketch one cycle of y equals cosine theta. So here is a graph of y equals cosine theta. Cosine theta graph always starts here at the maximum. And to sketch one cycle of it, trace along that curve until it begins to repeat. And right there is where it's going to begin to repeat. So that is one cycle. What is the amplitude of this graph? So here's the center line. The maximum distance above or below is 1. At any place, it's either 1 above for a maximum or 1 below for a minimum. So the amplitude is 1. So a new equation, y equals 3 cosine theta. So it takes this y equals cosine theta and introduces a 3 right there. Okay, so when I multiply by 3 and it's not inside the function, okay, if it was inside the function, it would say cosine 3 theta. 3 cosine theta is multiplying outside. That is a vertical dilation by 3. So we're going to sketch a graph of that. Okay, so my graph will have every maximum multiplied by 3. And every minimum multiplied by 3. Okay, so my graph is going to look like this. And when it's at the top or the bottom, it's going to be curvy. So it comes out of this in a curve. it meets this theta axis at the same point as it did before. Okay, so there is my graph of y equals 3 cosine theta. Okay, so we've sketched it. Now, what's the amplitude? So from the center line up, the amplitude is 3. So whatever number is right here in front of sine or cosine, that's going to be your amplitude. So a general form of that is y equals a cosine theta, where a is the amplitude. Okay, next graph, y equals cosine 4 theta. So this time, it's a horizontal dilation by 1/4. So instead of multiplying the y values by 3 like we did before, we're going to take our x values, which are actually theta values here, and multiply them by 1/4. Okay? So right here, my theta value is 0, times 0 stays 0. Here, my theta value is 1 pi. 1/4 of that is 1/4 pi. So here's a half pi, here's a 1/4 pi. When I'm at a maximum, my theta value is 2 pi. 1/4 of that is 1/2 pi. So I can start to see my pattern here. Okay, so this is going to be a really narrow cosine wave. Okay, so the question here is, what is the period? Because it's not the amplitude that changed. This time, it is the period that changed. So I'm going to trace one cycle of this graph. So I'll just start here and trace one cycle. And once I go any farther than that, it's about to repeat. Okay, so if all the way over to here is pi, then this is 1/2 pi. So my cycle goes from 0 to 1/2 pi, or pi over 2. So the period is pi over 2. So the general form of this, when I insert something here, is y equals cosine b theta. Okay, so that b will help us find the period. So the period is 2 pi over b. In this case, b was 4. So the period here is 2 pi over 4. And 2 over 4 simplifies to 1/2. So the period is 1/2 pi, or pi over 2.
We will end today with a little practice of evaluating sine, cosine, tangent, and even a reciprocal of one of those. So I would like you to be able to do this within your head only and not having to look at a picture of a unit circle. But for the purpose of me trying to get this across here, I think we'll just need a unit circle drawn. And I would like you to be able to just picture this in your head and locate pi over 6 just inside your head. So sine is a y value, and at pi over 6, it is up one position, so the y value is 1 over 2. Okay, negative 5 pi over 6. So we go clockwise, and we've got 1 6, 2 6, 3 6, 4 6, 5 6. And the cosine is the x value there. That is the third position left, which is negative root 3 over 2. And then 7 pi over 2, that's the same as 14 over 4. All the way around is 8 over 4. 9 fourths, 10 fourths, 11 fourths, 12 fourths, 13 fourths, 14 fourths. That's right here. Sine is the y value, and the y value down here is negative 1. 8 pi over 3, so that would be 16 sixths. All the way around is 12 sixths. 13, 14, 15, 16 sixths is right here. Tangent is y over x. So the y value here, this is the third position up, that's root 3 over 2. And the x value here, that's one position left, is negative 1 over 2. Okay, so we can do an outer loop here and get, we know our answer is going to be negative 2 root 3. And the inner loop is 2, and those will cancel, so we get negative root 3. Now, something we could do is if these denominators are the same, we can just cancel them out right now, and we're already at negative root 3 over 1. 3 pi, so we've got 1 pi, 2 pi, 3 pi. Right there, cosine, that is the x value, and right there the x value is negative 1. And then secant, that is reciprocal of cosine, so that is 1 over the x value. At 7 pi over 4, 8 pi over 4 is all the way around, so back 1/4, we are right here. The x value here is 2 positions right. The x value is root 2 over 2. So it's the reciprocal of that, which is 2 over root 2. Okay, so we will multiply top and bottom both by root 2 and get 2 root 2 over 2, which is root 2. As those cancel.